In this part of the lesson, we're going to continue with a measure of variability called the mean absolute deviation, otherwise known as MAD. So the MAD, again, is a measure that lets us know how spread apart our data is. The MAD helps determine whether the set's mean is a useful indicator of the values within the set. The larger the MAD, the less relevant the mean is as an indicator of the values within the set. So again, mean absolute deviation is a measure of variability. So the lower the MAD, the more predictable the data is. So we're going to take a look at our two sets of data, Jude's science grades as well as his math grades, and we're going to find the MAD, and we're going to determine if this indicates his data is scattered or if it's clustered. So the first part when you're calculating the MAD is we're going to list our values. I'm going to list them from the least to greatest. So we're going to list the data values here. '93, we have a '94, '96, and a '98. And then we're going to identify our mean. So the average of his grades was 85. We rounded to 85. So using this template, it's going to make finding the MAD much easier because we are being very organized. So the MAD is simply an average of the distance that each value is from the mean. So we're trying to see how far away on average is our data point from the mean, which represents the center part of our data. Then the next thing is we're going to subtract the data from the mean, and we're going to have some negatives. And the negative just tells me that this data point lies below the average. Then we're going to have some positives, and this means the data value, such as 88, lies above our mean. And then the word absolute comes from the fact that we're going to average these distances to get a single number to represent the distance. But we only want to look at the positive value. So we're taking the absolute value from our distances. And then we're going to average these. So our sum, when we add these together, is 95. And then we had 11 values total. And then when we average this, 95 divided by 11, we get a MAD value of 8.63. So that's saying that each of these data points is about 8.63 units away from the mean. That's an average distance. That's the MAD. It tells us, is our data spread apart or is it clustered close together? So let's compare that to the math grades, which we know were a little bit more consistent. So this MAD should be smaller. So again, we're going to arrange our numbers and we're going to list the data points. And then we're going to list the average of those data points, which was an average of 92. Again, you need to make sure you're nice and neat and organized with this process. And then we're going to subtract. And again, we're going to have some with negatives, meaning our data point lies below the average, and then some with positives. And you can already see these distance values are much smaller than the ones for his science grade. And then we're going to take the absolute value of these distances And then we're going to average these. So we're going to add these up and we get 38 and divide by the 11 values we have and we get 3.45. So you can see that each of these values is on average about 3.45 units away from the mean. So these data points were clustered close to our mean, especially when we compare it to his science grades, the MAD of 8.63. So again, just remember that the larger the MAD, the less the mean becomes as an indicator. And so as we just compared already, we can see that the MAD for his math grades is much smaller than the MAD from his science grades. And let's just recall that these measures, range, IQR, and MAD, these are all measures of variation, how spread apart the data is. If we have an outlier, we're going to use the IQR. If we do not have an outlier, we're going to use the MAD to describe the measure of variability. Just like you would use the median if you have an outlier over the mean. So our measures of central tendency. So let's back up here and let's just recap. So if you have an outlier, get a pen. This will be a good recap. If you have an outlier, for your measure of center, you're going to use the median. For your measure of variation, you're going to use the IQR because these are resistant measures. They are not affected by an outlier. If you have no outlier, for your measure of central tendency, you're going to use the mean. And for your variability measure, you're going to use the MAD. These are affected by an outlier, so use these measures when you don't have outlier. And you can see that range and mode are not very useful for either a center number or a variability number. I hope this helps.